Now that we understand about VLANs and trunks, let's imagine that we had a switched topology that looks like this. We've got 7 switches. These switches are interconnected with trunks. We'll say that they're IEEE 802.1q trunks, but they could be ISL trunks. And we want to add a new VLAN. Let's imagine that a new department has been created within this building. We want to create a new VLAN for that department. How would we do that? One option is we could go to the first switch and say, you have a new VLAN. You have VLAN 300. And then we would go to the next switch and we would say, let's create on you a new VLAN of 300. And we would go to the next switch and the next and the next and the next and so on. That's a lot of work. That doesn't scale very well to have to administratively add a VLAN on every single switch. Fortunately, if we do have a topology like this, we could take advantage of something called VTP, the VLAN trunking protocol. Don't be thrown off by the name. The VLAN trunking protocol, the name sounds like it should be a trunking protocol, a protocol that does trunking. It's really not. If I could name that protocol, I would call it the VLAN advertisement protocol, not the trunking protocol, because that's what it does. It advertises VLANs. Let's go back to our scenario where we want to create VLAN 300 on all of these switches. What we could do with VTP is we could create VLAN 300 on this top switch, and then we could send VTP advertisements out over trunk links. That's the way VTP works. It sends VTP advertisements over trunk links, only trunk links. And the next switches, when they see that advertisement, they could say, we now also know about VLAN 300. You see, we're automatically updating the VLAN databases in all of these switches. And the switches that receive the VTP updates, and they add VLAN 300 to their database, they could then forward those VTP advertisements on to the switches beyond them. Suddenly, everybody in the topology knows about VLAN 300. It's added to everyone's database. And there are several VTP options that we can set when we're configuring VTP. First of all, in our topology, do we want to be able to go to any switch and add or delete or modify VLAN and have that change propagated to all the other switches? Maybe not. What we could do is go to one switch and say, you're operating in client mode. If we have a client mode switch, it will receive VTP advertisements. It will update its local database to reflect this newly learned information. It will still forward VTP advertisements. What we cannot do on a client is connect to that client and administratively add, delete, or modify VLAN. The way that client's VLAN database is going to be updated is through VTP advertisements. Well, if that's a client, what's a server? A server is a device, such as the one we began with. It's a switch on which we can create, modify, or delete VLANs. Can we have more than one server in the topology? Yes, we can. We can have multiple servers, we can have multiple clients. There's one other option as well, and that other option is a transparent mode switch. Let's say that this switch is operating in transparent mode. With transparent mode, yes, we can go to that switch and administratively add, create, or modify VLAN, but that change is only taking place on that switch's VLAN database. That transparent mode switch is not blocking VTP advertisements. If we receive a VTP advertisement in from a server into a transparent mode switch, no problem, it will forward it on. It's just not going to update its local database based on that advertisement. And before we get into the configuration, let's make a really clear definition of these 3 different modes of VTP.